Here's a question nobody asks at the dinner table. If you left Earth today, not metaphorically, not in a dream, but actually climbed into a ship and fired the engines and just went, where would physics itself finally stop you? Not your fuel, not your courage, not some alien civilization. Physics. The universe has a boundary that isn't a wall, isn't a sign, isn't even a place. And the strangest part? We crossed part of it already. You were born on the wrong side of a cosmic horizon and nobody told you. Let's fix that. I want to be upfront with you about something before we go any further. Most of what you've been told about space travel, about limits, about distance, about what's possible, has been either incomplete or quietly wrong. Not because anyone lied to you, but because the truth is so strange, so genuinely disorienting, that most people flinch away from it and replace it with something simpler. A rocket that goes fast enough. An engine we just haven't built yet. The idea that if we're clever enough, that's a beautiful idea, and it's wrong in a very specific way. A way that once you understand it doesn't make the universe feel smaller. It makes it feel like something was given to you, something enormous and specific, and yours. And that's what I want to give you in the next 15 minutes. Not just the physics. The feeling of the physics. Because I've spent a lot of time thinking about nature, about the way the universe actually works underneath all the stories we tell about it. And I've come to believe that there's nothing more liberating than understanding a real limit. Not a limit someone imposed on you, a limit that's built into the fabric of everything, and that still, astonishingly, leaves you more room than you could ever use. So let's build the room in your mind before we fill it with the numbers. Because a number without a story is just noise, and this particular number deserves walls with good acoustics. Imagine an ant, a very determined ant walking across the surface of a balloon. This ant has a destination, a small red dot it spotted a moment ago across the curve of the balloon's surface. The ant starts walking. It's moving at maximum ant speed. It's pointed in exactly the right direction. It has every intention of reaching that red dot. But while the ant walks, someone is blowing the balloon up. Not the air inside, the balloon itself, its surface, is expanding, growing, getting bigger in every direction all at once. And here's the thing that makes this example so slippery. The red dot isn't moving away from the ant in any ordinary sense. It's not running, it's not being pulled. The space between the ant and the dot is simply getting larger, the way the space between two dots drawn on the surface of a balloon gets larger when you blow air into it. Neither dot moves. The surface between them grows. So the ant walks, and the dot stays ahead of it, and the ant is doing everything right. It's moving as fast as ant physics allows. It's aimed correctly. It has unlimited motivation, but the game has rules the ant doesn't know about. And nobody updated the ant's rule book. Now here's what gets me. That ant isn't failing. It didn't make a mistake. It just inherited a universe with a particular shape, and that shape has consequences. The question isn't whether the ant can walk faster. The question is, how big is the balloon right now in the region the ant can still reach? And is the answer worth getting out of bed for? We are that ant. This solar system, this little rocky planet, is the ant's starting point. And the balloon is the universe itself, expanding in every direction right now as you watch this, carrying galaxies away from us not because they're moving through space, but because space itself is stretching. And the question I want to answer is, how big is our reachable balloon? How far could we actually go? The answer is going to require us to understand a few things first. And I promise I'll explain every single one of them in plain language, because the math behind these ideas isn't what's beautiful. It's the ideas themselves, naked and strange, and lit up like something alive. Let's start with the speed of light. You've heard this before. Nothing can travel faster than light. Light moves at about 186,000 miles per second. In 1 year, it covers roughly 5.88 trillion miles, what we call a light year. And the common assumption is that the speed of light is the problem. That if we could just crack that limit, build an engine that could somehow push past it, we'd be free. The universe would open up. But here's what nobody tells you. The speed of light isn't the problem. It's actually a gift. It's the universe's guarantee that information and matter can travel at all, at a speed that's fast enough to make an enormous, ancient, expanding universe navigable, at least in principle. The reason the speed of light feels like a cage is that we've been thinking about it wrong. We've been thinking about it from the outside, as something imposed on us. But if you think about it from the inside, from inside a ship actually moving at close to the speed of light, it looks completely different. Here's the secret that changes everything. Time slows down when you move fast. I'm not being poetic. I'm being precise. Albert Einstein showed us, and we've measured this, with atomic clocks on airplanes, with particles in accelerators, that the faster you move through space, the slower you move through time. They're not separate things. Space and time are one fabric, and speed through space trades against the passage of time, directly, measurably, mathematically. What this means for a traveler is extraordinary. Say you build a ship that can accelerate to 99.9% of the speed of light. Not faster, not at it, just very close to it. From outside the ship, from Earth, from the perspective of everyone you left behind, it would take thousands of years for you to cross any meaningful cosmic distance. But inside the ship, time is crawling. Your clocks tick slowly. You age slowly. A journey that takes 10,000 years from Earth's perspective might feel like a decade to you. You step off the ship, 70 years older in your body, having covered a distance that would have taken your species 10 millennia at any slower speed. This is real. This isn't science fiction. This is what the equations say, and everything we've ever tested confirms it. The universe doesn't punish speed. It doesn't lock the door and throw away the key. It says, go faster, and I will give you more distance per heartbeat. It's a trade. The universe exchanging your connection to home, your shared time with everyone you love, for personal access to more cosmos than any slower traveler could ever see. So with that engine, with that near-light-speed ship, a single human lifetime of traveling could carry you across the Milky Way, across the gulf between us and the Andromeda Galaxy, across unimaginable spans of space, all felt from the inside as a normal human life. You would age normally. You would get hungry at the usual hours. You would read books and fall asleep and dream. And all the while, the universe would be compressing its distances into your personal experience, folding itself into the shape of a thing you could actually cross. But, and here's where the balloon comes back in, not everyone gets to make that trade. Back on Earth, time keeps moving. 1,000 years pass. 10,000. The people you left behind, their children, their children's children, all the civilizations that rise and fall while you're in transit. They experience every second of that time. You arrive somewhere incredible, but home has changed beyond recognition. Time dilation is physics saying, you can have the universe, but you have to choose between it and your home. Every explorer who ever climbed into a boat and sailed toward an unknown horizon has faced exactly this. Physics just makes the cost more honest. Now let's talk about how far that ship could actually go. Because here's where the balloon analogy becomes critical, and here's where most people's intuition breaks down completely. The universe is about 13.8 billion years old. So you might assume the universe is 13.8 billion light-years in radius. That light from the moment of the Big Bang has had exactly that long to travel, so the edge of what we can see is that far away. That's a perfectly logical thing to assume. It's also wrong because the universe has been expanding the entire time that light was traveling. A photon that left a distant galaxy 13 billion years ago heading toward us, that galaxy has been moving away the entire time the photon was in flight. So by the time the photon arrives and we detect it, the galaxy that sent it is no longer 13 billion light-years away. It's much farther. The observable universe, the sphere of everything we can see in principle, with a perfect telescope, is actually about 93 billion light-years in diameter. not 13.8. 93. The expansion of space stretches the canvas while the light is still crossing it. That's the observable universe, everything whose ancient light has had time to reach us. But the reachable universe, the region where a ship could actually go, if we started traveling today and kept going forever, is smaller. And the reason it's smaller comes down to one of the most unsettling discoveries in the history of science. In 1998, two independent teams of astronomers were studying distant supernovae, stellar explosions so bright they can be seen across billions of light years, trying to measure how fast the universe's expansion was slowing down. Because everyone assumed it was slowing down. Gravity pulls things together. The Big Bang sent everything flying apart. Surely, over time, gravity would be winning, gently decelerating the expansion, perhaps eventually reversing it into a big crunch. What they found instead made the hair stand up on the backs of their necks. The expansion wasn't slowing down, it was speeding up. Some energy embedded in the fabric of space itself. Something we don't understand and have named dark energy purely because we needed to call it something, is pushing space apart at an accelerating rate. The universe isn't just expanding, it's expanding faster and faster with every passing moment. Both teams won the Nobel Prize, and the universe quietly kept doing what it had apparently always been doing. Here is what dark energy means for our balloon, for our reachable universe. There is a boundary, a horizon beyond which galaxies are already receding from us faster than light can travel. Not because those galaxies are moving through space at superluminal speeds, which is impossible, but because the space between us and them is growing so rapidly that even light moving at its maximum speed cannot close the gap. The light from those galaxies was able to reach us in the past because in the early universe the expansion was slower and the distances were smaller. But a photon you sent toward those galaxies today would never arrive. It would spend eternity traveling toward a destination that recedes faster than it can approach. Those galaxies are gone, not destroyed, not dangerous, just permanently, thermodynamically, irreversibly beyond reach. We can still see their old light. We can study their ancient signatures, but we can never go there, and they can never come to us. It's like receiving a letter from someone who has already died. The words are real, the person was real, the love in the message is real. But you cannot write back. The address no longer exists in any accessible form. Now, in the region inside our cosmological horizon, the region where space is not yet expanding faster than light, there are still an estimated 2 trillion galaxies. 2 trillion, each one containing hundreds of billions of stars, each star with the possibility of planets. The reachable universe, the region where physics would permit a ship traveling indefinitely to eventually arrive, is enormous beyond any number your nervous system was built to process. If the Milky Way, our entire galaxy, 100,000 light-years across, home to 300 billion stars, were shrunk to the size of a single grain of sand, the reachable universe would be the size of a sphere containing every grain of sand on every beach, on every continent on Earth, stacked 50 miles deep. That's your inheritance. That's the yard the fence was built around. And we haven't left the grain of sand yet. But here's the paradox that I keep turning over in my mind. The one that wakes me up at 3 in the morning and makes me grateful to be alive right now at this exact moment in history. We are almost certainly never going to use most of it. Not because we lack the will. Not because we'll destroy ourselves, though that's a possibility worth taking seriously. But because the Milky Way alone, just our own galaxy, just our grain of sand, would take 100,000 years to cross at the speed of light. Even with time dilation compressing that journey for the traveler, the logistics of exploring 2 trillion galaxies within any meaningful time frame are not engineering problems. They're mathematical ones. There simply isn't enough time, even with a civilization that lasts billions of years, to send ships to everywhere we could theoretically reach. And yet, and this is what I want you to sit with, the limit isn't a reason for despair. The limit is a definition. It tells us exactly what we have, It draws the shape of our cosmic home with a precision that should make you feel, if you let it, something close to wonder. We are not lost in an infinite, shapeless void. We live in a very large, very specific, very measurable neighborhood. And within it, there is more to discover than the entire history of human curiosity has so far accumulated. Every star we've ever named, every planet we've ever imagined, every civilization we've dreamed of in the dark, all of it fits inside this boundary, with room to spare that the word vast doesn't even begin to approach. There's one more thing I want to tell you about, because I think it's the most philosophically interesting part of all of this. And it's the part that connects the cosmic to the personal in a way I can't quite shake. The horizon is not fixed. It moves with us. If we left today on a ship heading toward any galaxy inside the reachable universe, that ship would, over time, be closer to its destination and farther from home. Its local horizon, the region around it where physics still permits travel, would shift. Galaxies that were previously unreachable would slowly become reachable as the ship crossed into their local neighborhood. The horizon isn't a wall you hit. It's a sphere centered on wherever you are. It expands with you, in the directions you choose to move. What is permanently unreachable from Earth might become reachable from a ship halfway across the Milky Way. The horizon moves with you. You carry it. You are, in a sense, the lighthouse, the center of a sphere of possible futures that shifts with every direction you choose to travel. I want to slow down here for a second, because this is the part where the physics stops being about space and starts being about something closer to home. Every human life has a horizon, not a cosmic one. There are things in your life right now that are still reachable but receding. Relationships that haven't yet crossed the point of no return. Versions of yourself that you could still become if you aimed at them and moved. Projects and conversations and long-delayed honesty that are still, today, within the sphere of your possible future. And there are things that have already crossed the horizon. People you lost. Versions of yourself that you left behind. Opportunities that receded past the point where any amount of speed can close the gap. And you can still see their light. The memories, the lessons, the ways they shaped you. That light is real. It matters, but you cannot go there and recognizing that isn't defeat. It's navigation. It's knowing which direction to point the ship. The practice I want to offer you is simple, but it asks something real of you. Sit quietly, not right now, but sometime today, and draw 2 circles in your mind. The first circle contains everything still within your reach. The conversations you haven't had, the things you've been meaning to start, the people you still have time with. The second circle contains the things that have crossed the horizon, the griefs you're still trying to reverse, the futures you're directing energy toward that are genuinely, permanently gone. Most of us spend enormous amounts of time and emotional fuel aimed at the second circle. We point ourselves at unreachable destinations and burn everything we have trying to get there, while the first circle, full of real, available, extraordinary possibility, sits waiting. The physics doesn't judge this. The universe doesn't punish it. But it does tell you with beautiful mathematical clarity that your fuel is finite and your horizon is real. Point yourself at what's still inside it. And then, this is the second practice, move at your maximum speed in your chosen direction. Not someone else's maximum speed. Yours. Time dilation is personal. The person moving fastest relative to their own life's constraints gets the most life per heartbeat. This doesn't mean frantic. Frantic is moving in 10 directions at once, which is not moving fast, it's moving noisily at very low net velocity. Maximum speed in a chosen direction looks calm from the outside. It looks like someone who knows where they're going and has stopped arguing with themselves about whether to go. What direction is that for you? I'm genuinely asking. Not as a rhetorical device, because I think most people know, somewhere under all the noise, where they actually want to point the ship. The physics just gives you permission to take the question seriously. The third practice is the one that costs the most, emotionally. It's the one that requires the most courage, Grieve what's already crossed the horizon. Not forever. Grief isn't an indefinite process. It's a function with a shape. But actually grieve it. Name the thing. Say out loud or write down, "This is gone. I can still see its light. It shaped me. But I cannot go there, and I'm going to stop aimed at it." Because here's what I've noticed about people who do this. Not just in thinking about physics, but in thinking about living. The moment they stop pointing themselves at the unreachable, the first circle comes into focus. The reachable universe suddenly looks different. It looks vast, in the way our actual cosmic neighborhood is vast, more than enough, more than you could ever exhaust, more than you deserve and have anyway. 2 trillion galaxies inside our cosmic horizon, and we have the rest of time to explore them. Let me bring us back to where we started. You asked, or the title asked on your behalf, how far humanity could travel, and physics gave us an answer, a real, measured, testable answer. The reachable universe extends roughly 18 billion light-years in every direction from where we sit right now. Within it are 2 trillion galaxies, hundreds of billions of stars per galaxy, possibly trillions of planets. And time, flexible, negotiable, bendable time, that gives a single human traveler on a near-light-speed ship more personal distance than they could ever exhaust in a lifetime. The cosmological horizon isn't a ceiling, it's a definition. It defines the size of our forever home, and it's incomprehensibly, embarrassingly generous. The universe is generous right now. It is showing us billions of galaxies through our telescopes, sending us their ancient light, letting us study their composition and their motion and their age. And dark energy, that mysterious accelerating force, will slowly, over billions of years, close the curtain. Galaxies currently at the edge of the reachable universe will eventually cross the horizon and go dark. In 150 billion years, the Milky Way and its small gravitationally bound neighbors will be effectively alone in a vast, expanding, emptying cosmos. The curtain will be mostly closed. But right now, the stage is lit. Every direction is open. The physics of this particular moment in cosmic history, 13.8 billion years after the Big Bang, before the expansion has claimed most of what's currently visible, happens to be the most generous configuration the universe will ever offer us. We were born in the right era. We got here at the right time. Not by accident, not by design, just by the extraordinary luck of being made of the right atoms in the right galaxy, in the right window of cosmic time. You are not standing at the edge of the possible. You are standing near the center of it. The horizon isn't ahead of you. It moves with you. You carry it. You are the lighthouse. And somewhere right now, a photon of light is traveling away from a galaxy that has already crossed our horizon. A galaxy we will never visit, from a star that may no longer exist. That photon doesn't know it's unreachable. It doesn't experience the irony of its situation. It's just doing what photons do, moving at its maximum speed, in its chosen direction, carrying its small piece of information forward into the dark, without apology, without hesitation, without any concern for whether anyone will receive it. That's not a bad way to live. That's actually the only way to live. If something in this video shifted something in you, even by a small angle, even just enough to look at the sky a little differently tonight, hit the like button. Not for the algorithm, though the algorithm does appreciate it, but as a small acknowledgement that this mattered, that the physics mattered. And if you want more of this, science that takes your actual life seriously, not just the cosmos, subscribe. I'll be here, moving in my chosen direction, at the only speed I know how to go, which is as fast as I can, aimed at whatever is still inside the horizon. The universe gave us an enormous, specific, measurable home. The least we can do is explore it.